Hello everyone, and welcome to yet another recreational programming session with Mr. Zozin. So, lately I decided that I need to get into ARM development, right? So because throughout the entirety of my career I've been doing only x86-64 development and also a little bit of a WASM and stuff like that, but ARM is sort of like a second most used architecture in the wild, and I know almost nothing about it. I really know almost nothing about it, and I had it on my to-do list for way too long. I think the time has come to actually explore this beautiful, interesting platform. Well, this is actually not true. I just randomly remembered that I also commercially did mobile applications, and the mobile applications worked on ARM, but I never really directly worked with the ARM assembly, right? So it was just like, it all was abstracted away from me with the layers of abstractions and stuff like that. So I don't think I can count that, right? I don't think I can count that. So like, here's my plan how to get into the ARM development. I want to install an ARM Linux distro, on QEMU, right, on QEMU, and then just use that for different experiments and different projects, right? So, and we discussed what kind of distro to use in the pre-stream with the chat, and chat suggested Alpine, which kind of makes sense to me, right? So it's a very simplistic distro. I don't need to have like a server-side distro or desktop distro. I just need some sort of simple distro, and Alpine actually kind of fits into that really well. On top of that, since it's so simple, it's been ported on all sorts of architecture, and as you can see, ARM is even sort of the first one, which is kind of ironic. So I think it's a perfect candidate for this kind of thing. Right, and I also just randomly remembered that long time ago, I had a pretty funny project. I wouldn't call it project, right? So because it's literally just two bash scripts, which is called Wisp. Right. So when I used it, when I actually needed to host my bot, I think I hosted my bot through this entire thing. I think somebody's setting off fireworks, but anyway. So basically, Wisp is a set of simple scripts for setting up small QEMU-based virtual machines. Right. That's what it is, and it's literally two shell scripts. Right, so one shell script allows you to install a distro. So the way you use it is that you download an ISO, right, and then you just use install with Arch, by the way, x69420, and then the name of the image, a hard drive image, your MQ completely forgot about this shit. Okay, so you use the install script, and it will automatically create a hard drive, the image for you, and use the ISO to like install the thing. You'll have to do that manually, and then you can just run this QCOW image with a particular port, and then you can SSH into that particular port. I think this is a pretty good way of working with QEMU machines. Right, so I can even just like install Alpine, ARM Alpine, and maybe run it on one of my other machines, like, you know, an old laptop. Right, so it doesn't consume resources on my streaming machine, and I can SSH into that and do some R development there. Sounds like a pretty good plan. Right, so Wisp is a set of simple scripts for setting up small QEMU-based virtual machines. Because I'm an old boomer who hates Docker, don't hate me. Well, I mean, yeah, and honestly, Docker wouldn't even help us with this kind of thing, because Docker is not an emulator. Right, it's not an emulator, right? So if you're running on an x86-64 machine, like, you're not going to magically get ARM unless, as the chat said in the pre-stream, you use QEMU backend. I mean, like, you're already using QEMU, you don't need Docker, like, it doesn't make any freaking sense. So the problem with the scripts, if I remember correctly, they only work with x86-64, exactly, they only work with x86-64, so they're not gonna work right away for us, right? So we'll have to modify it. Maybe this specific thing should be sort of a parameter of the script, right? So essentially you will be able to customize which architecture you want to use. So in any case, let's actually clone these two scripts. I'm actually gonna put them in here in the chat and also in the description, right, in this description. And let's freaking clone this thingy. So it's Tsoding, and I think I don't have it cloned yet. So because it's a very old project, it's a really old project, and the last commit was like literally 3 years ago. Yeah. So it's pretty old. It is pretty old. Meine Freunde, pretty old. Okay, so Wisp. And what do we have in here? So if I remember correctly, in QEMU, like you have a system and you have all sorts of architectures in here. So, and here is the ARM, but I heard that ARM is actually 32 bits. If you want to have ARM, which is 64 bits, you have to use AArch64. Long. So it's not just long arg, it's a long arg. I have no idea what that is. What the fuck is this architecture? There's so many. Damn, there's so many different architecture, right? So the only things I know is x86-64. I know ARMS. I know RISCs. I know MIPS. Microblaze, I don't really know. PowerPC, I know this kind of thing. Spark, I heard about this thing from Last Miles. And so this is something from Motorola, if I'm not mistaken, right? So this is something from Motorola. I don't really know what is long arch. Yeah, but anyway. So let me actually go to this entire thing into the Wisp. Actually, I know a lot of architecture if you think about it. Okay, so let's download the, this is Arch, we don't need Arch, fuck Arch. We need this thing. And I suppose I'm going to put Alpine into the description, right? So because it's part of the references. So that's what it is. So can I just like click without any redirection and just do wget, boom. Alrighty, it is downloading. I hope it's not going to get an hour to download. It seems to be pretty fast, right? So it's going to be half of a minute. Install Gentoo and be happy. I think it's going to take more than 2 hours to install Gentoo, right? Because like usually you basically compile everything from scratch, don't you? Right, I'm pretty sure you compile on everything from scratch in Gentoo. Okay, so let's actually do TeamUX. And like I know that it's not going to work, but let's actually kind of try to run Alpine in here. So here, how should I call my image? How should I call my QCow image? Should I just use whatever I did in the readme, your mom, QCow 2? Yeah, your mom, there we go. So, and it doesn't seem to be working, right? So, well, I mean, it's trying to do things. Yeah, it couldn't load this entire thing. Right, so yeah, no bootable device. That's understandable. So now, no boot found. That's really funny. So it was trying to do boot D. So it's a very old, yeah. So boot D, and this is probably because I forgot to put slash in here. How did it work before without the slash? We already found a freaking bug in here. Okay, so that's pretty good. It's still not going to work because we're using x86-64, right? So it's not probably going to be bootable. Yeah. Right, let's actually not do anything in here. So let's do AArch64. At some point, we need to customize it. One of the things we can do in here, we can do Arch, right? So, and by default, maybe it's going to be x86-64, right? So this is your architecture. And then you can put this architecture in here. Honestly, this is kind of a cool idea of naming, right? So you basically encode an architecture as the name of the executable, though you could have actually made it like a flag for the QEMU, but I mean, anyway. So now if I do something like this, so this is going to be AArch64. Let's try to run it now. And well, I mean, wasn't it QEMU system AArch64? No machine specified and there is no default. No machine specified and there's no default. So that means you can't just use literally the same flags for QEMU or Arch64. You can't just do that. Okay, so let's actually see what this error means. All right, so we're gonna try to Google it up because I'm pretty sure I'm not the only one who encountered that error before. Which computer to emulate? Huh, that's very interesting. Like I do not understand why when I try to select this thing and just like copy paste, thank you so much, right? So show me what's the problem. Emulating ARM. Okay, so that's exactly our problem. So let's take a look at the gist. Right, so does it say this entire thing? No machine, okay. ARM, So I could not manage to make it work. I got the following message. ARM no machine specified and there's no default. Use machine help to help supported machines. Ah. So somebody is doing a guess. So ARM is usually so system on chip, right? So this is what SOC means. And QEMU doesn't know which SOC. This is interesting because ARM, there is no such thing as ARM, right? So ARM is sort of like a flavor. Yeah, this is very interesting. It's just a flavor, right? So, and I didn't think about that. Okay, so that kind of makes sense. So virtual, okay. So let's actually see. And I suppose to do like a machine help, right? So machine help. Oh, holy shit. Okay, so which one should I use? Facebook, блять, Facebook, блять, сука. Alright, so Canon, FBI, high mark. Oh, high mark, or high bank. Okay, so it's not high mark. So which one should I pick? Which machine should I pick? Do you guys have any suggestions? Oh, there's Raspberry Pis. There's different Raspberry Pis. Okay, so which Raspberry Pi should I use? Right, so maybe 0 for B. There's an empty machine, so so empty. Is it going to work though? So there's also 0. Oh, you mean the Raspberry Pi 0. Okay, so here's the plan. We can try an empty machine, or then we can try a Raspberry Pi. Right. So there's also Vert. People suggesting Vert. I'm not really sure what the fuck is Vert. So it's just like a QEMU. Oh, and it's all deprecated. Well, I mean, it's, yeah, so you have to do something like this. It's a QEMU flavor of a virtual machine. Of ARM. QEMU flavor of ARM. So it doesn't even exist in reality. This kind of like thing doesn't exist at all. Right. So it's basically a virtual machine that just has ARM processor. But anyway, so let's actually try machine none. So because of that, I feel like this entire idea of this variable is kind of pointless. Unless you maybe have another one, arch machine, and this is where we're gonna do none, right? So, but then it only makes sense if your architecture is arch, right? So I'm not even sure how to handle this entire stuff, because if it's x86-64, it's not gonna make any sense, right? So if I do x86-64, ooh, wait, a machine is also applicable to x86-64. Huh. But I suppose for x86-64 it does like really matter, so it's just a PC. So PC is more or less like a well-known thing. Huh. That is pretty cool. Okay, so that means maybe we can have a machine flag just always, right? So we can say machine, right? So this is going to be machine, and this is a machine none. Right, machine. So I'm using 4 GB of memory apparently, and this is going to be a machine. All right, so I'm learning something about this entire stuff. So, okay, so install, right? So let's actually try to install this entire thing. Invalid accelerator. Really? I don't have a KVM accelerator? I can't... Do I have to install something for KVM? Fuck. Okay, so that's kind of sad. You cannot do KVM. Ah, that makes sense, bro. Yes, that makes sense. Like, if you are on x86-64, how the fuck you expect to do KVM on Arch? All right. That makes sense. So what's the easiest way for me to do that? So I'm gonna remove it for now, but it will be kind of nice to just like, I don't freaking know, to do something about it so it's enableable and disableable. It would be kind of cool to be able to just like build command lines before trying to run them in bash, similar to how I do that in Nob. Right, honestly, lately I find Nob more convenient for running external programs than shell. As ironic as it sounds, I think it's more convenient because I have more flexibility in how I construct this kind of thing. Xarg, maybe we can use Xarg, but unfortunately I'm not that really familiar with Xarg. So I need to learn their language to properly use it. So anyway, thank you so much, Anonymous Gifter, for gifting the sub. Team Scar, thank you so much for Twitch Prime with the message. Hello, Mr. Zozin, hope you're doing great today. What's your favorite type of schnitzel? I don't know, the one that contains meat. Well, I mean, if it has meat, it's already good, right? So it's just like that's everything I have to say. So anyway, CodeCat69, thank you so much for Tiavam with the message. Hi, hello, Roman Go Empire. Thank you so much for the prime. Thank you. A rare schnitzel. Yeah, it's a rare schnitzel. Rare schnitzel question. Yeah. Anyways, so I'm not really sure how to go about it. So maybe I can just have something like this, additional virtualization or something like that. But anyway, so you know, KVM. I don't know. Should I call it like extra flags? Right. So, and those extra flags is going to be something like this. Extra flags. Like this. Is that a good idea? I'm actually not sure. So, and in here we just have an empty thing. And obviously ISO path is something like this, right? So for now, if it's x86, right, if it's Arch, it's going to be that. We also want to have a machine there, but I don't freaking know. Anyways, let's give it a try. HD your mom drive exist. So the thing it tries to do, it tries to just create this drive, and if it already exists, I suppose it exits. Right, maybe let's try to remove this entire thing. And I don't quite get it. So what's the problem? Drive with bus 0 unit 0 exists. Because the machine none. Okay, so we literally can't use... Chat, why the fuck were you suggesting the none machine if we need a hard drive to install shed on? Like, did I get debated by chat yet again? What the fuck is this scheisse? Excuse me. So you can use it, but you have to use device to add extra stuff. Okay. Okay, I can see. QEMU system, a Arch machine help. Right, so let's actually use maybe Pi. Right, so Raspberry Pi. So the latest one, what's the latest Raspberry Pi? Latest Raspberry Pi. What's the latest one? It says 5. You don't even have 5 in here. Get freaking damn it, old ass QEMU. So this is the latest one. It's the Raspberry Pi. So somebody's saying things in here, so which are probably important or interesting. So CD-ROM and HDD are both drive 0. You need to use HDB. Maybe that's what I have to do. But I mean, okay. So, but how is it related to machine none? Is it something else, right? So can I keep machine none and then use HDB in here? If not, this has something to do with different problem in here. I'm solving this problem in here. So I don't freaking know. Vert was made to literally to emulate. So do I have to use Vert? I don't know which one to use. Chat is just saying random different things that are conflicting to each other. I have a one specific... Okay, I'm gonna ignore the chat, right? So because the chat is just saying conflicting things, right? So what we're gonna be doing, we're gonna be just exploring things. That's the whole point. So none doesn't have... What if I... right, so people were saying to use Vert. So let's go ahead and try Vert, but let's actually try the latest one. It just has alias to the latest one. Okay, so let's give a try to Vert one and see if it's going to do anything useful. Okay, so let's do install. And all right, okay, so it doesn't matter if it was Vert or not Vert or something. So Sifon suggested to use HDBA, right? It suggested to use HDBA. So device need media, but drive is empty. Okay, so none of that actually worked. Okay, Vert also didn't work. Word also didn't work. Let's actually try then Raspberry Pi. So rasp. So again, like if you are currently you know, have an aneurysm because I'm doing the wrong thing and I'm not listening to the chat and don't read documentation, you can only blame yourself because you're saying random conflicting shit that is not helpful, and that's why I don't read you. So you can only blame yourself, right? So I'm just exploring and I'm just trying things. If you think I'm doing something wrong, good. Be mad. You deserve it. Anyways, so let's actually try to do this kind of thing, and again, it doesn't work. Okay, so let me see. QEMU, Arch. So hard drive. So how can I attach a hard drive? So there's a QEMU and this kind of thing. So mounting USB hard drive in QEMU, none of that is particularly helpful. Oh yeah, of course. So that's pretty cool. So Arch. And what's interesting is that the error message is not particularly helpful, right? So it literally doesn't say anything, right? It literally doesn't say anything. It's just like HDI drive with 0 bus unit 0 exist. Okay, so maybe another thing we can try. Arch64 load ISO. Right. Running an ISO style image of ARM. Okay, so this is some sort of from UK, right? So this is from UK. So let's see if the British tag is actually better than American one. Okay, so here we are creating an image, right? So here with QEMU image, we create an image. This is literally what we do in here, right? So create 20 gigabytes of that. Then what I have to do, right? So Arch, I'm probably not going to be using CPU host, right? So like none of that makes sense because we are running all of that on x86, 64, like we can't really do that. So there is non-graphic. I want to have a little bit of a graphic, or by non-graphic, they mean you're not going to be displaying images or anything like that. I don't freaking know what that's supposed to mean. If you're running on things using KVM, we're not doing KVM. Alternatively, for software simulation, try this one. So CPU Cortex A53. Do we have to do that if we're doing virtual? I don't really know. So you have to use these flags for the drives and stuff like that. So yeah, okay. So that kind of makes sense. So this is what we're supposed to be doing in here, right? So that sounds more or less, unless it is generated by ChatGPT, we don't freaking know. And it's kind of annoying that QEMU has this like weird flags that also change from time to time. Right, it's just like why on x86 I have to do CD-ROM and HDA, HDB, but then all of a sudden all of that changed because it's not, you know, clean architecture or something, and now we have to use these drive things. I don't fucking know. They like to change things over and over again, so that's it's kind of weird to me. But anyways, so there is var store image, Debian image. Like what the fuck is that stuff? Like, do I really have to do that? Can I not do any of this shit? Right, so the firmware create both images to hold UEFI variable store. It's for storing the UEFI. You unzip this kind of thing. Do I need EFI just to store? Like, can I just install it as x86 64? Can I just install? Like, do I need EFI? This is so stupid. Like, I don't want to be doing that. Like, if I don't do that, well, obviously we have to put some stuff in here. So this is a row. This is going to be ISO path, right? So this is ISO path, and this is QEMU EFI, Cortex A. Okay, so that's kind of weird. So Debian network installer. Okay, so let's actually download this thing. And what is this? And it's not even file. It's some random ass website, and it doesn't even have this thing. Doesn't even fucking have this thing. I don't freaking know. Like, I feel like maybe I don't have to do that, honestly. I have a feeling that I just don't have to do that. Like, let's not do that. Let's not do that at all. none of that shit. So, and here is the image itself, QCow image, right? So let's give it a try. So will that work? Maybe that will work. We'll see. We'll see. All right. So your mom is removed. Right. So let's just go ahead and try to run it one more time. Well, it is thinking, and it's also doing something that we asked it to do, which is no graphics, which is good. And I can't control C this thing, by the way. I literally can't control C it. I wonder if I can find QEMU in here running somewhere and just literally kill it, because it's not okay. So I am capable of killing it. All right. So I feel like, right, so I want to have a window because I need to have some sort of an input. Otherwise, I won't be able to input anything. Right, let's go ahead and just try to remove no graphics, right, because we want to have graphics. And we do have graphics. Right, look at that. Look at that. So we don't really have anything except the QEMU console, right? So, and I wonder if I can maybe increase the size of this entire thing. So zoom to fit, like we can't do that. We literally can't do that. So, but yeah, I can do help, and there is a lot of things in here. Can I quit the whole thing? So we managed to quit. So when it doesn't really do anything, because it probably needs EFI. Control Alt Plus didn't work. So I'm trying Control Alt Plus, it doesn't work. But anyways, so we've got at least something, right? So we got at least something from this specific article. So that means it is kind of worthy of being mentioned in the references in here. So which is kind of nice. Okay, so they also talking about something called QEMU EFI, right? So QEMU EFI, what the fuck is that? So using EFI, and nobody really talks about it, and maybe so. Oh yeah, I didn't use, what is it called, a VPN. So that means I should be able to open Reddit, because when I use VPN, Reddit is unopenable for me at all. Okay, so how to put QEMU in EFI mode? This is x86-64. This is x86-64, and you need to find this stuff. If you use, okay, the chat, I'm gonna read the chat noise, which is conflicting, it's not helpful. If you use device word or device Raspberry, it will just work without all the BS. So, but if it doesn't, can I permaban you from the chat? So, is that a good idea? Is that a deal? Right, I can try that, but if it doesn't work, I can, okay, so, all right, so let's go. So let's do a machine vert. Wait a second. Is that the alias to... Oh no, 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 oh no, 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 no. Oh no, no, no. It's like, you guys understand why I don't listen to chat anymore? Or like, do I have to use device, right? Was it device? Right, so was it, I don't remember, device vert. Okay, so this is machine, device vert, okay. And I can try to replace this thing with machine. This is why I don't fucking listen to chat. This is literally why. It's just because it's fucking useless. Anyways, so they just say things, right? So they just think things without thinking. It's just like a random shit. It's worse than LLM, honestly. Anyways, right. So maybe is there some instructions, right? So maybe we should actually Google for specific instructions, like install Alpine iArch64 on QEMU. Has anyone, yeah, on QEMU iArch. Right, it's just like, why do I have to tweak all of these weird little things? It's just like, how can I install it? Just install it. Install Alpine on QEMU. Okay, so they're talking about this scheiße. Okay, so that's... Oh, finally! Thank you so much, Alpine developers. Thank you, thank you, thank you. We finally found... What the fuck is this x86-64? Brovsky! I don't care about x86-64. I know about that stuff. Bro, this is useless. Didn't I say I said a arch. Oh, fucking useless. Install Alpine on QEMU. Skill QEMU Alpine. Okay. Okay, cool. And a arch 64. Installed it SSH. This is literally my scripts, aren't they? Okay. Okay, so we're talking... Bias. Fucking bias. You can set bias. Drive, QCOW, whatever. Why do you all disable graphics, right? Don't you want to see what the fuck you're doing? Why are you all disabling graphics? Are you crazy? Right. So, and do I have to download this file from somewhere? Like, can we even take a look at what this flag mean? So, arch bias help, because for machines I can do help and get the list of the machines. But for the bias, can I do that? No machine specified and no need default. Okay, so what if I specify vert? Okay, so cannot find ROM. You literally need to have that freaking ROM. Okay, so, and for the machine they use vert, and but maybe they are kind of installed system-wide, right? So what if they are just installed system-wide and this is where it searches for them? No, it doesn't exist. One of the things I may try to do, maybe search for that specific name, or maybe even just like roughly something that resembles this name in /user. It's supposed to be actually put in here, so there's something like this. I'm pretty sure I won't find anything, right? So we didn't find anything particularly useful in here. We can try to Google up some of that stuff in here. So it's kind of like a image in here. So does it download? Oh, what the fuck is this? What the fuck is this? Oh, right. Oh, shit. You have to download that from Debian. Guys, I'm starting to think that running Linux on QEMU is kind of an unsolved computer science problem, because you're literally stitching together solutions from different distros. You have an Alpine, then you have a bias from Debian, and just like kind of try to... Holy shit. So how, like, is that the shit the Linux distro developers have to deal with on a daily basis, by the way? Is that what it feels like to develop a Linux distro? Or something like that? How does it feel to develop something like Asahi Linux, right? Something that is completely unexplored and you literally have to like reverse engineer this kind of stuff. So it's kind of insane. But anyway. So let's actually try to download this entire thing and see if it's... Okay. But maybe Void has something. So guest agent. So there's a QEMU tools. There's no EFI. QEMU firmware. It's installed, isn't it? But what we can do, we can just see what kind of files do we have in there. Not bad. Once in a while, chat says some intelligible things. Right. So, and what do we? Can we just have like what is it called? AVV. I don't see shit. Chat. Yeah, AAV. No, it doesn't have that. But which one do we have to use in here? So there is a bunch of FDs. So there is this one. This sounds like the one that we need. AArch64. Right. So this sounds like the one that we need. Yeah. Okay. So let's actually try to put this thing as a bias. So, and in here, and look at that, it uses a different style, like CD-ROM, and here we're using like a different thing. Like, which flags do the fuck I have to use? Like, which flags do I have to use? I don't freaking understand. Is that like a flag aliases? Right, so are they like equivalent or something? It's just like QEMU is kind of weird in that regard. Isn't QEMU and FFmpeg created by the same person? Speaking of weird flags, yes, okay, that explains the flag situation. Yes, so it explains the flag situation. Well, I mean, it's kind of cool. I'm not saying that QEMU and FFmpeg are bad. These are good projects, right? But I'm just saying that's kind of ironic that they kind of have a similar confusing flag situation. Makes you think. But anyways, so let's try to maybe. I didn't want to do that. Where is the install? Didn't fucking work. Okay, so maybe we have to use the same scheme in here as like in here. So let's do CD, CD-ROM for this kind of thing. So this is ISO flag. All right, and for the drive, we use qcow file something. And by the way, we have to use format qcow, right? So otherwise it just like doesn't particularly work. So this is what we have to use in here, right? So format qcow, CD-ROM, bias is this one. So we use the same CPU. Cores, we have a lot of cores. We can actually add a bunch of cores for our CPU because why not? Why not? We can afford that because as far as I know, I have like 16 cores, right? So I have 16 cores. All right. So let me see. So can I just do that? Okay. Could not open equal your mom. Huh. This one is interesting. I'm an idiot. So I have to do something like that. Boom. No, none of that worked. No, none of that works. So it's just if you want to avoid all of this, try QEMU user static. Like again, chat's just saying things. It's just noise. Just ignore the chat. Okay, so RTC. So there's other things in here. So maybe we're not going to be doing acceleration. Right, so no graphic nick. I may add these additional things even though I'm not quite sure what they do. So let's give it a try. So all right, this is what we got, and yeah, it just like, do I have to do start? Right, can I do, like, I can't see, like, more, maybe more, yeah, there's, oh, I can actually scroll in here, can I? Yeah, none of that is helpful. None of that is helpful. The problem is that no graphics device. Yeah, but I didn't explicitly say no graphics, didn't I? So do I have to enable some stuff? No graphics. There's no graphics. There's no graphics. And do I have to start something? Like, I don't even know what it is doing. So device RAM FB. Okay, so chat is just saying things, right? So device RAM FB. Like, you literally don't know what you're talking about, right? Holy shit! Who said that in the chat? Holy fuck, somebody knows what they're talking about. What the fuck? Ah, thank you. Thank you so much. VIP, yeah. So who said RAMFS? Ah, how can I... and it doesn't load up, but at least we actually kind of advanced. Right. At least we kind of advanced. RAMFB. So who said that? So Tiago, okay, so you get a VIP for saying that. Right, there you go. Enable to achievement page in your dashboard to learn. Okay, we ran out of VIP slots. I'm sorry about that. So it is what it is. I'm a small streamer. Anyways, we got Alpine, motherfuckers. We got Alpine. So, yep, we can finally continue. It's unsolved cock-putter science. It's a science of putting the cock, and it's unsolved cock-putting science. But we're kind of getting closer. We're kind of getting closer. So that's pretty cool. I wonder if I can zoom in or zoom to fit. Can you see Scheiße, meine Freunde? Meine Freunde, meine Freunde. I wonder, okay, maybe this was the problem all along. Right, so maybe that was the problem all along, and we don't really need like a lot of stuff in here. So maybe we can cut out on some of these things, but I'm not 100% sure. For example, if I don't have a bias, right, so will it still work? Okay, so yeah, it cannot work without the bias, so it kind of needs the bias. Right, and then it can actually start. So starting boot option, Tirana core. Okay, so how do you install Alpine? Installing Alpine. So you're supposed to probably get into the root without the password. Okay, I see what's going on. I see what's going on. So this is going to be zoom to fit. So first we have to log in. We have to log in and then set up Alpine, and it will like walk us through the process. I suppose that's how it's going to go. All right. So it's a root. Oh, fuck. I have to. Okay. Of course, the keyboard don't just work. Of fucking course. Okay. So QEMU keyboard device. Mouse and keyboard not working in QEMU. So how do I fucking do anything with that? So like, why is it so? Okay. So USB device host device virtual keyboard device, I think. Okay, so we can give it a try. Wait, I know your nickname. Fuck off. No, I'm not listening to that. So you're the one who suggested some version and didn't, like, I'm not listening to you. You should be banned, by the way. You agreed to get banned. So that's straight about. Can try no graphics. I also know your nickname, and I also don't know why the fuck you still have VIP. But we can try. Let's actually try no graphics. Right. So no graphics. Right. I'm pretty sure it's not gonna work. No graphic. Just a single no graphic. Okay. Oh, you mean in a sense that it's now gonna be doing this kind? Okay, I see. I see what you guys suggesting. So it's gonna be in here. All right. So you're not gonna lose your VIP today. Don't worry about it. You're not losing your VIP today. OpenRC. Okay. So what the fuck is OpenRC? OpenRC. This one is interesting. Dependency based init system. Ooh, it's what Alpine actually uses, right? So it's just like OpenRC. Okay, that's pretty cool. Okay. So let me see. So we have to use setup Alpine. Okay, can you see Scheiße? Enter host name. Okay, so let me just bring this up a little bit. So it's probably gonna fuck up the sub chat, but that's fine. Okay, so what's gonna be the host name of this thing? What's gonna be the host name? because it's a small. Your mom is a VSP, right? So no, your mom is not going to be that. Penger, yeah. So yeah, Penger. I think it's a pretty good name. All right, so this is a host name. So available interfaces are Ethernet 0. Okay, so enter question mark to help on bridges, bonding, and VLANs. Okay, so which one do you? Okay, so let's use Ethernet 0. Ethernet 0. So IP address. Let's use DHCP. Right. Do you want to do any manual network configuration? Hell no. Okay. So this is basically our network. So what's going to be the password for the Penger? So I'm going to type bonding. Bonding. So bonding is the password for Penger. So what's going to be the time zone? Let's maybe use UTC, right? So let's just use UTC, whatever. And we're installing things. So HTTP proxy, none. We're not going to be using any HTTP proxy. Which NTP client to run? BusyBox, Open, Coroni. Which one do you suggest, chat? Which one do you suggest? NTP client. NTP client. None. BusyBox. What about a beatbox? No? Okay. So let's use Coroni. Who needs BusyBox when you got a right? So APK. Isn't APK an Android shit? Or am I missing? What the fuck is APK? Android. Yeah, it's an Android scheiße. It's an Android. Like, what the fuck is this scheiße? Okay. I suppose it's also Alpine package managers. Okay, so who stole from whom? Chat. Can you tell me who stole from whom? Android from Alpine or Alpine from Android? What do you guys think? Alpine stole the name. Based. If Google stole the name, fuck you, huge corporation. If it's the other way around, based. Anyways, so so what do we have to do in here? Enter mirror number or URL. There's no numbers in here. What the fuck do you want from me? Okay, so show mirror list. Oh fuck. Is there anyone in Russia? Maybe. So there's a Chinese. So CN is Chinese, right? If I'm not mistaken. I think. Alpine. Who? F. There's no F. Oh, you're okay. Infania. Poland. Kurwa mać. Ja pierdolę. Okay, we're gonna be using Polish one. You know what? I'm gonna be using Polish one. All right, let's go. Set up a user. Enter a lowercase login name. Okay, so this is gonna be Penger. Maybe no. You know what? Like, I'm not really sure. Do we need to have a user in this machine? I'm gonna be doing experimentations. So maybe always have like a root access. Is that a good idea? I'm not sure. You know what? I'm not going to be creating a user because we can always create a user later, right? So we have a root access and stuff like that. So let's actually do no. Which SSH server? Drop bear. That's a very interesting name, but I'm going to be using OpenSSH. Okay, so we're installing Scheiße. Allow root SSH logging. No. I think yes, right? So because I don't really have any other way to log in into this machine yet. Maybe at some point we can reconfigure it, but then it's just a setup, right? It's just a setup. So it's not like I'm going to be exposing it to the internet or anything like that. So enter SSH key or URL for root. Oh. That's an interesting idea. So no, we're gonna do none. Okay. So which disk? So let's see. I suppose I just put VDA, and it's 20 gigabytes. It's the your mom QCOW that we actually created automatically. Okay, so this is VDA. How would you like to use it? Okay, can you just like automatically use it for everything? Oh, you mean... okay, so it says... Can I maybe decrease the size and do something like this? There's a lot of things in here. So this mode is a traditional disk install. Okay, so I suppose it makes sense to use the traditional one. Let's use the traditional one. All right, let's fucking go. Can you scroll up? Maybe I could. All right, so because I'm in QEMU, so maybe I could have done that. So erase the above disk and continue. Yes, erase it. We created it from scratch specifically for you, Alpine. Make FS fat. Is Alpine gonna be installing FAT32? Like, what the fuck? Why are you making MakeFS fat? Oh, it's a UI5. Okay. I say it's a UI5 partition. All right, makes sense. Listen, I haven't reinstalled Linux for quite some time. Well, I never installed GNU/Linux. I always had somebody to install it for... I'm so sorry. So you guys know, it's just like RMS never actually installed GNU/Linux, right? So because... anyways, so we're just waiting for this thing. Yeah, I know that I can scroll on QEMU. I just forgot. I just forgot. So yeah, like, you see, I can scroll in QEMU. I know how to do that. I swear, chat. I swear, I know how to use computer. Okay, I know how to use computer. Generating group. Ooh. Absolute charging. Absolute charging. Okay. So can I just shut down? So shut down. I can't even shut down. I don't want to reboot. I just want to... how do I do power off? Ah, okay, so it's a power off. Yeah, I remember that there is also like a second command to do power off and stuff like that. Yep. Okay, so that's pretty cool. So that was a collective effort, and we got the your mom QCOW. Right, which contains ARM Alpine Linux, which is kind of cool. So now we need to run it somehow. So I suppose I'm gonna hack run SH script in a similar fashion as I did the install one. So let me literally copy paste this command in here. So maybe we're gonna have like a separate set of commands for x86-64 and for ARM AArch64. I think that's fair. Okay, so in here, what do? We should not do CD, right? We don't do CD. So then this is the usual stuff. We just load, yeah, so it's basically the same parameters. By the way, I also use no graphics in here, right? So specifically so I can actually access it like that. So in terms of networking, I remember one of the things I did in here is that I set up the networking device. So this is the networking device, and I basically sort of like a forwarded SSH, but I'm not sure if I need to do it right now. I don't think I need to do it right now. So I only did it for like hosting the bot so I can then SSH over that thing at some point. Why ARM? Because I want to learn ARM. So yeah, so because I always programmed and dealt with x86-64, and I just want to learn something new. I know it is usually frowned upon in the modern tech to learn new things, because in a modern tech, you're supposed to be dumb, you're supposed to be wipe coder that just clocks in, does stupid shit and clocks out. You're not supposed to understand things. This is not what you paid for. But I'm left tech long time ago, so I can allow myself to actually learn things and improve myself. Right, so that's why ARM. That is why ARM. So anyways, so let's actually see what we can do in here. So I'm supposed to actually provide the port, but maybe it doesn't matter for us right now. So let's try to do run your mom QCOW. So there was some errors, so I'm not really sure what's up with all that. Yeah, we definitely need like a separate set of scripts in here for x86 and AR64. UDHCPC. ICPC. ICPP when IP. Oh! Crony D. Busy box. So, what was the password for bonding? Oh, hell yeah, it worked. Do I have... Hell yeah. So, you name A. There we go. Ooh, ooh, ooh. Do I have Sissy? I don't have Sissy. How am I supposed to run C programs? Chat. What the fuck? So, GCC... Okay, so we'll probably have to install all of that shit. We'll probably have to install all of that. APK. Alpine. Alpine package manager. Well, I can probably do something like APK. Not APL, but APK. There's no man. Okay, so APK help. We have at least that. Alright, let's take a look at that. By the way, can I ping? Oh, fuck. Oh, shit. I don't even have an internet. Ooh. So do you have IP address or something like that? Okay, so we'll get that. So what's the... I don't see... Right, so this is the thing. But what's the gateway? Do you see... How do you see gateway? I don't remember how to see gateway. It's just like one, right? Try wget. Yeah. Anyway, IP are... yeah. So source... This is the gateway, isn't it? Right? Or I think this is the gateway. Telling ping won't work with user space networking, but other protocols should. Ah, I see. I see. So this is, yeah, so this is the gateway, and I wonder actually, for the ping, yeah, so this is a gateway, and I'm curious, so do I have NC? I do have NC, and can I NC listen? So if I do port, I'm pretty sure I have to use port somewhere here. So port 6969, right? So, and then in here, can I ping this thing? It's not particularly pingable, but I thought maybe I can actually access this kind of stuff. And before network 101, well, I mean, I'm a programmer, not a network person. So I was thinking that maybe I can do NC 20215 port 69 and just test. Nah, it doesn't do that. Anyway. Anyways. So APK. So what was the help, right? So, and let's just do... Control A doesn't really work well for me. What I want to see, by the way, is how to update. So update repository indices. Okay, so APK updating the repository. Okay, so it worked. So, and ping doesn't work in user space, blah, 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 whatever. Okay, so can I upgrade this thing now? Can I just upgrade it? Okay, so nothing needs to be upgraded. So we can do list. So to list, holy shit. And I suppose you're supposed to search in that list using grep. And do I have GCC? Okay, so you can have GCC in here. So yeah, we can try to install GCC. So apk help, and I suppose it's simply install or it's add. Yeah. So it's probably add GCC. Let's fucking go. I just learned the new package manager. Isn't that impressive? I know so many package managers, chat. Look, I know APT, I know XBPS, I know Pacman, and now I know APK. Isn't that impressive how many package managers I know? This is how you sound like when you ask me how many languages I know. It's all the same shit. Anyways, so we've got GCC. right? So we got GCC, and I suppose we can try to maybe, yeah, program a little bit, main.c. So I'm gonna do something like this. And this is, I suppose, an original VI, right? So this is an original VI. And what we have to do is just put something, can it, yeah, okay, so 1, 2, 3, 4. So because when I press tab, it actually inserts tab, which is 8 characters long, which is kind of dumb in my opinion. Just saying, hello world. And now I should be able to do main.c. Not mean, main, I said. Okay, so, well, at some point that should have happened in my life, but I mean, alright, so that's very minimalistic. That's a truly minimalistic distro. That's a truly minimalistic distro. Okay, so some people suggesting to use like a libc or something like that. Let's actually see. Right, so can I do libc? It's probably how to be something like this. Okay, so some people said interesting things, which is install musl, right? Install musl. Musl like this. So musl is already installed, but then we have musl dev. Okay. apk add. So we're gonna be using musl then. We're gonna be using musl. All right. So I can try to do gcc main.c. Absolute choding. Fuck yeah. Fuck yeah. So if I take a look at the main, oh fuck. File, really? How? Okay, apk list grep file. Oh, it's gonna be a tough one. It's gonna be a tough one. How? So, well, I mean, we can say that it probably starts with file. Yeah, it's probably just file. apk install. Oh, well, I mean, it's add. Add. Absolute choding. Okay, so lsb pi executable arm. There we go. So we got arm. We actually got arm executable. This is fucking poggers. This is absolutely freaking poggers. I really love it. Okay, so do we have obj dump? We do have obj dump. Babaji dump. All right. So let me take a look. Main, something like this, I'm pretty sure. There we go. This is the ARM assembly. I have no idea what the fuck this shit means. Yes. So today's stream was literally to get to this point where we're looking at ARM assembly and I'm being confused about it, like, holy fuck, what the fuck is this shit? 31, whoa, yo, for real, I didn't think about that. Okay, so we can try to guess what it is. Okay, so there's a move instruction. I wonder what this instruction does. I never worked with ARM, I only worked with x86-64. It's a completely different architecture. I wonder what this instruction does. This is how you look like when you're trying to learn second language. It's all the same shit. Okay, so, but I don't know what is STP. So this one is interesting. So I suppose registers are just like X's, right? So you have X0, X1, X2, and they're general purpose registers. Okay, that's understandable. So there's also SP, and I suspect that SP is a stack pointer. That makes sense, right? So because in x86-64, there is RSP. What's interesting is that you also do this thing. You're probably subtracting 16 bytes from SP, effectively allocating some memory. And this is probably what it does. So I'm not really sure what is STP, but it accepts 3 arguments in here. So what I suspect it is doing, right, so it's probably 3 address code. It's a 3 address code. So it probably takes an operands from second and third address and then kind of saves it into this one, right? Because then it uses this one, x22, to save it into ASP, which, by the way, tells me that the order of the arguments is here, like for move, is probably this is the destination and this is the source, right? But in here, it's kind of weird in a sense. It's kind of weird in a sense, so I'm not really sure. Maybe this is some sort of like subtract or something. I'm not 100% sure. I'm not 100% sure. So this is probably some sort of a prelude, right? So this is some sort of a prelude. So yeah, I do not fully understand this one. So this is add, and it's definitely you adding some stuff to x0, right? You definitely adding some stuff to x0, and then you do puts. So then you kind of recover the stack, I suppose, and then you sort of return. Okay. Do not fully understand everything, but it's, I suppose it's kind of workable. I suppose it is kind of workable. So the thing is, I don't know a single ARM assembly that is kind of similar to FASM. Do I really have to use x86-64 Scheiße? What do you guys think? Do I have to use x86-64 Scheiße? Oh, like GCC Scheiße, that's what I mean. Do I really have to use GCC to program in ARM? Yeah, so this is what I said. This is what I thought, right? So I probably have to use, you know, GNU assembly. Does FASM support ARM syntax? FASM is a little bit complicated. Okay, so FASM is a little bit complicated in the sense that FASM, the first version, yeah, so you know what I'm talking about. FASM first version was purely x86-64 assembly. Then Thomas Grichter, the creator of FASM, created the second version of FASM, which is actually built on top of FASM-G. Right, and FASM-G is sort of like an engine for creating assemblers. So essentially, it's a meta language that lets you create different architectures as libraries. So that's the thing. Right, and the idea was that x86-64 is going to be one library, ARM is going to be another one, and so on and so forth. But as far as I know, FASM-G is not that actively used, right? So it's just like, I don't know how well it is supported and how well it is going to work and stuff like that. And I feel like if I'm going to start using this kind of thing on a stream, it's going to be a huge rabbit hole, which I'm never going to be recovering from. So yeah, I don't know. Doesn't ARM make their own assembler? Maybe, but I mean, we can just use gas, right? So just like a GNU assembler and stuff like that. All right. Anyway, so let me think. So ARM, Linux, GNU as hello world example. Just a simple example, I think, is going to help us, right? So there's an ARM developer, so this is an official ARM, and they have a hello world example. I hope I'm not banned on their website. Yeah, I'm probably banned. Fuck. Oh, on x86. Okay. ARM.com. Hello world tutorial on x86-64. Are you sure that you're ARM.com? Okay, so I'm banned. My IP is banned in there, so whatever. Okay, so hello world in ARM assembly. All right, so this is gas syntax. This is gas syntax. Okay. All right. Assembling. So this is ARM, Linux, Android. Let me see. Do I have as? I do. Right. So, and by the way, I think I need to install man. Let's install man. You don't have man. What the fuck, man? Man, what the fuck? Grep man. Oh, it's a man pages. Okay. Probably have to do man pages. Alright. So it also probably makes sense to install maybe development pages. If I do man as man wait Brovskis. I should have actually done grep man. So man pages, I probably have to install man doc, don't I? Right, so that's what I have to do. Install man doc. Freaking, why didn't I call it install? Because because like I have a reflex. There's also mandb, but I mean I didn't see mandb honestly. So okay, there we go. So as so what's funny is that there was also dev. So maybe we need to have devil. Wait, I remember grep man. What was that? Man pages POSIX. So yeah. Man pages POSIX. But I'm not sure if it's going to work, honestly. Nah, doesn't do that. But I mean, you can always do something like help. Yeah. That's one way to do that. That's one way to do that. Bin utils doc. Well, we can try to do that. APK list grep bin utils. Yeah, there is a bin utils doc. Look at that. So, and let's just do add. It works. Look at that. Thank you. It's kind of weird. Like, I mean, I would expect that corresponding main pages are installed by. Well, I mean, it's a pretty common thing to put documentation in a separate package. I don't know what I'm talking about. Anyways, so maybe we should follow this sort of tutorial, right? Does it sound like a good idea? Sounds like a good idea. I think we should try to do that. So do we have just a Vim? APK list grep Vim. Do we have Vim? Yeah, we do have Vim. Because I want to have a little bit of a syntax highlighting, you know? Just a little bit of a syntax highlighting. I'm going to do add Vim. And let's freaking go. Main.c. What? Excuse me? Is this really? So, I didn't expect that, honestly. And it also does some color scheme. Okay, color scheme. So there's not that. It's absolutely freaking broken, by the way. It's just like, I think it identified the terminal incorrectly. Yeah, so the terminal, I have to set the terminal in a particular fashion. Yeah, so that's something. So term x something something something. So we can try to. I can't even copy paste it. I'm trying to copy paste this specific message because I think it is saying incorrect. Chat, stop moving. Chat, shut up. Okay, I'm trying to. Yeah, there we go. All right. Thank you so much. So can I do something like Vim? Oh fuck. All right, we're not gonna have Vim then. We're not gonna have Vim. So chat is useless as usual. So I suppose we're gonna be using VI without any syntax highlighting. Oh, somebody made a mistake. Well, it's on you. That's why I don't listen to chat, because you're debating me all the time. No, we're not gonna have any syntax highlighting. It's all on you. It's all on you. Anyways, right, so we're gonna do main.s, and maybe I'm gonna actually split this entire thing like a little bit. And I suppose we need to have an entry point. So this is the entry point, right? And I'm gonna just leave it as it is, right? So maybe I'm gonna do return. There we go. So how do I assemble this entire thing? I can try to do main.s, and did it create anything? Okay, apparently it maybe did, but I have too many things in here. Okay, so I want to create like a hello, and I'm gonna move this thing to hello, right? So then I'm gonna remove main and a out, so that's pretty cool. And I'm gonna create like hello asm, move main.s hello, you know, hello asm. Let's go there. Cool. So if I try to do something like this, it created a.out. It created a.out. What is this file? What is this file? It's yeah, it's a LSB relocatable. I suppose what we should have done, we should have actually maybe outputted main.o, Right, so, and this is what we've got in here. And after that, I suppose we have to link it, right? So here is assembling, right? So you kind of creating an O, and then we're using linker in here. We're using linker. And by the way, it uses flag S. I'm not really sure what the fuck is that flag, but maybe it is needed or not. And okay. Omit all symbol information from the output file. Why would you use that? Like, I mean, I don't think it's necessary in here. So we're gonna be just using LDO and whatever. Okay, LDO main.o. Cannot find symbol underscore start, and this is exactly what I expected. This is exactly what I expected. So what we have to do in here, we have to mark it as global, right? So because here, as you can see, we have to mark it as global. You have to spell it like this. There we go. So, you know, we probably have to install make, right? So apk install make. I think with the make, it would be reflexes, man. I can't help myself. Why APK developers didn't create an alias for install? Like, I know that it's add, but I mean, in majority of the package managers, it is install. You want to have add, keep add. But if you just edit an alias, that would have been such a good, like, quality of life improvement. It's kind of weird, right, that they didn't do that, but I mean, okay. Add. I mean, I understand that add is shorter, right? So, but anyway. Okay, let's create a make file. By the way, I think I need to remove Vim. We don't need Vim anymore. Fuck Vim. We're gonna use VI. We're gonna use VI, the most base text editor. So I want to create main. It depends on main O, and in here we just do LD main O. That's what we're doing in here. Okay, so to create main O, we depend on main S, and we use as O main S. Right. So and then we do something like this. Boom, we created an executable. Look at that. It segfaults. It does in fact segfault. Why does it segfault? Because we literally don't do shit. We just return. I suspect this is literally the same situation as with x86-64, right? So you have nowhere to return. To end the execution of the program, you have to call the exit syscall, right? Exit syscall. So let's actually see how you do that. So to call a syscall, you use the instruction SVI with a 0 operand, because I suspect that dollar is literal, it's immediate literal, right? It's not any register or anything like that, because registers are usually the percents, right? So it's immediate literal. It would be kind of cool to have a reference guide for all of the ARM instructions. So let's actually put this thing in here, right? So because this is the hello world that we're going through. So ARM SVI instruction. So what is this instruction? So SVI, and I don't have an access to developer arm.com because it is banned in Russia, because Russians may accidentally access it and learn how to use this dangerous technology and use it against the civilized world. So that's why it is banned in Russia, even though I can probably get it by using VPN, but I can't really stream with VPN right now. So maybe I should have actually, you know, yeah, we can use a Wayback Machine, right? So Wayback Machine. Russia uses ARM for missile law. So as you can see, banning, you know, ARM.com in Russia actually helps it not to not use it. So as you can see, it actually works. The problem is actually solved. So anyways, can we just access this kind of thing? All right, so not available. So it was never actually saved. Can I just save it in the Wayback Machine? Okay. So we have to sign in to actually do that. So there's a PDF. I didn't want to open PDFs, but I mean, we can try to do that. Okay. So thank you so much. SVI. Software interrupt. Okay, this one is interesting. I see. So that's what it is. It's a software interrupt. It's kind of a similar to int instruction in x86-64. And as far as I know, for syscalls, interrupt instruction in x86 is still used for 32 bits. So it is still used for 32 bits. Isn't that PDF for 32-bit ARM? So that means in 64-bit ARM, it is not a software interrupt, but it's something else. Right. I mean, okay, so it's a wrong one, but does it mean that SVI in 64 bits is something else? I didn't think so. It kind of makes sense that it's still software interrupt regardless of the bits. So on x86-64, this is what is used for syscall. So it's kind of similar in here. So there's also SVC. Huh, very interesting. So SVC, what is that? There is no SVC, okay. I don't see the SVC. Well, I mean, they kind of mention it, but there's no information about it. Okay, so we know that it's a software interrupt, at least, right? So we know that it's a software interrupt, and it's probably just a syscall. So here we set up a status, right? So we have to set up the status. So we move. Well, I probably have to do something like R0. Right, R0, and then we put immediate value of 0 in here, and that is the status. Let's actually put 69 in here to confirm, right, that this is how you control the exit code. All right. So then in R7, I suppose we put the number of the syscall, right? So this is the number of the syscall, and it's going to be 1, right? Okay. So can I actually run external commands from here? Okay, I can actually do that. That's pretty cool. Expected a register or register list and operand move. Huh. It didn't work. That is fascinating. So is that because I have to SVI 0? So I have to do something like that. So it's 3. It didn't like something about move. Ah, it's for 32. Ooh, yeah, it's a 32. Fuck. This is a wrong guide. This is actually a wrong guide. So this is Android NDK. So that means we'll have to find something else. So ARM ARCH64. But I mean, we kind of close, I think. Okay, so there is a similar guide for ARM64. Okay, that's pretty cool. Yeah, and it's it's SVC, right? So it's SVC, and I think somebody actually gave a link in here, right? So yeah, so let's actually put all of those things into the description, right? So this is that one, and also here is the SVC guide, right? And there was also a PDF somewhere that we used. I think all of that has to be in the references. So here is the PDF. Right, because all of that was helpful. I'm trying to capture everything that was helpful throughout this journey. Right, so all of that was helpful. So, and since this is 32 bits, so this is 32 bits like this, and this is 64 bits, and this is where we have this thing. So supervisor call causes an exception to be supervisor call. This is such a fascinating concept. Supervisor call. This looks so fucking cool. A supervisor call is a hardware instruction used by Interesting. So I suppose a System 360 by IBM was also using kind of the same terminology, right? So, but I mean, I suppose we're talking about ARM. I can't really access ARM.com, but I mean, it's kind of interesting. So instruction generates SVC. A typical use for SVC is to request privileged operations or access to system resources from an operating system. Okay, so it's kind of similar to how x86-64 works. Right, so originally in x86 in 32-bit mode, you used interrupts to ask operating system do something, and then in 64-bit versions, they introduced syscall instruction. It's kind of similar in ARM. So ARM kind of mirrors x86. So why? So far, ARM just feels like a different flavor of x86. I thought it's going to be like completely kind of different, but it's just a different flavor of x86. Is that true? Like, again, I never had experience with ARM before this stream, like a real experience with ARM. So it just like feels like a different flavor of the same shit. So the current instruction. Only so many ways to make a useful CPU. True. That sounds fair. So more like Intel 64 takes a lot of lessons from ARM. Oh, okay. Okay. So parallel code is more perilous. I don't know what that word means. I'm sorry. Anyways, so let's continue. Like, we need to get to the point of hello world, right? So if we achieve hello world today, I'm gonna call it absolute trading moment. So let's freaking go. We have to move, so we have to use X. And what's interesting is that they're using like a different flavor of assembly as well, right? So you just do X, and then we're saving. So immediate values, they now have a completely different syntax. So they use hashes and stuff. Okay, so then we use a register. Well, in here, by the way, we probably want to put 69, right? So this is a 69. So then in here, we just do 93, and this is probably the syscall, the exit syscall, which is a rather big number for a syscall, honestly, which is a rather big number, and it's actually a supervisor call. Okay, let me try to call an external command, and it worked. So, and now let's exit. And if I try to do that, it doesn't segfault. Remember it segfaulted before? It doesn't segfault. And now if I take a look, what is the exit code of the previous command? It is in fact 69. Absolute choding. We can control exit code. We can control exit code. We can change it to something else. Right, so we can do main S. Right, and now I can do maybe 32. Right, make run echo 32. Look at that. We can control exit code. So that's pretty cool. So what's the next thing? I suppose we want to actually put like a 0 in here. So that's totally fine. So the next thing is write syscall. Write syscall. This is rather cool. So the arguments are for the syscalls are literally x0, x1, x2. And then the code for the syscall is just w8. I would like to know what kind of registers do I have in ARM. Let me close everything that is irrelevant to what I'm doing. arch64 registers. Okay. So there's in Russian, so I'm gonna open this one. So this one is also closed. Arch registers and instructions quick start. So general, holy 31. So refer to generally to use registers. Then another 31 x64 bit wide access same registers. Oh shit. Bro, wait a fucking second. This is so fucking awesome. I can port ports on ARM and I can use general purpose registers as the stack, as a limited size stack. Right, so essentially, since I know the size of, in ports, there is one interesting thing about ports is that I always know the size of the stack at compile time. I always know the size of the stack at compile time. So that means at compile time, I can treat access as basically like a stack like this, right? And essentially say, right, okay, so I pushed two numbers, they're stored in x1 and x0, and that's basically the top of the stack, right? I can just basically treat it as an array, right? And it's where I store the stack. So, and it's automatically all in the registers. CPU pipelining is gonna go crazy. Is it? So it's too bad for CPU pipelining. You can't index the register. I can at compile time. That's the thing. I can index them if I know the size of the stack at compile time. Right. Because I know how many of them is stored at compile time. So I can do that. I didn't see any problems with that. This is actually kind of cool. And this is something that I did with the Beam virtual machine, because Beam virtual machine has thousands general purpose instructions. Maybe, by the way, if I learn the second, platform, ARM platform, I may have enough inspiration to recover port series to port ports to ARM, because why not? Why not? So sounds like fun, right? So we'll see how it goes. We'll see how it goes. But anyways, so that's a lot of registers, and yeah, so it's a pretty good platform. I mean, it's 2025. We have to have a lot of registers, right? So we can afford a lot of registers. Honestly, we can just afford that. Stop being poor. Give me thousands of registers. Just give me thousands of registers. Anyways. So this is a move, and in here I'm just moving the standard input, right? So this is the number of the standard input. LDR is a sus instruction. What the fuck is LDR? I suppose it... LD probably stands for load. R probably stands for register. Or address, or it's probably load into the register, address into the register. So that's what it is. Because essentially what we have in here is... so it's basically the message where we store all of that stuff. And also... But why do we use this kind of thing in here? I'm not quite sure, because is that loading an address or loading a value? I need to read the definition of this instruction. So let me see. So LDR, can I do something like that? So LDR, immediate. There's 3 flavors of LDR. It stands for load registers, but you can load immediate value, you can load literal, or you can load register. So there's 3 variants of this thing. Okay, that's pretty interesting. A load register immediate loads a word or double word from memory and writes it to a register. So you can load it from memory. Okay. So literal calculates an address from PC, program counter or something like that, value, and immediate offset loads. So yeah, it's kind of like, it's the same instruction, but it's used for kind of different situations. But anyways, I get an idea. So, and I suppose if we want to just do x1 message, we have to have that message defined somewhere. Right, so here's the message. And here we say that it's an ASCII, hello, arch64. And we also put n in here. What's funny is that we don't put null terminator. This is because it's right, it operates on the size of the of this thing. So, and I suppose then we compute the length. Dot probably means the current address minus the address of the message, and equals probably means that it's sort of some macro, right? So it's sort of some macro. Okay, so and then what we're doing here is LDR x2 equal len. And I suspect that these 2 instructions are actually different flavors of LDR. That's the thing. Even though it looks like it's the same instruction, it feels like the same instruction, even syntactically, it's actually 2 different instructions. Because here, we're loading the address of the memory. Yeah, I think dot, my hypothesis is that a dot is the same as the $, because otherwise it doesn't make any sense, right? So this is my hypothesis. Right, so here we're loading an address of the message, but len is a length which is a single immediate value. So this one is loading address into the register, and this one is loading immediate value into the register. This is actually 2 different instructions. This is my hypothesis. I hope I actually understand correctly. Obj dump it back after compiling. That's a good idea. So we're going to obj back and just see, because obj dump shows you the sequence of bytes, right? It shows the sequence of bytes. We can actually confirm that it's 2 different instructions. All right. So and then here we now specify the number of the syscall, right? So it's going to be 64, and then we just do supervised call, which is 0. Okay. So can I now compile this entire thing? It compiles, and now. If I do something like Absolute shredding. Absolute shredding. We achieved Hello World on AArch64. Absolute fucking shredding. That's actually cool. That wasn't that hard, honestly. That wasn't that hard. So yeah, I have a playground for ARM development. That's so fucking cool. And what's funny is that this is do I have LDD? So this is not a dynamic program. Well, so if I just do something like file, it's statically linked. Can I run it on my mobile phone? Can I ADB shell into my mobile phone, upload this executable there and run it? And it will say hello from ARM64, if it's 64, right? But I don't know if it's 64 actually. But I don't know if I'll be able to write into its file system. If the syscall numbers are compatible. That's a good point. We don't know if it's compatible. There's only one way to know. Okay, so first of all, we want to do the obj dump. Babaji dump. All right. Look, it supports callers. Like, it's just Vim couldn't properly recognize shit or anything. Anyways, so main and stuff. Where is the? Oh, it's a start. Okay. It's all still relative. Look at that. It's kind of the same, honestly. It's kind of the same. But I mean, maybe they are the same, actually. Maybe they are the same. Kind of hard to tell. Kind of hard to tell. So, and it's all relative. So here is the message, and it's just a bunch of words. It doesn't really tell us. And it's also relative load. Look at that. Wait, does equal create a value in static memory? I feel like it does. Doesn't make any sense to me, honestly. Okay, so here is the message, and it ends with 0A. So this is a new line, and our hello world also ends with new line, right? So this is how we know that that message thingy is actually like doesn't have anything after it. Okay, so 64, this is a 4 bytes value, and then we get 88. So then, so it's a start plus 28. So did it put it somewhere in a different place? 10. It's 16, right? So I'm pretty sure it's 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It created a value. It created a 32-bit value in the code itself, and it loaded it from a pointer. Here it is. Here's that motherfucking value. I thought it's immediately loaded. Because it loads this thing, right? So it's B0. Here is the 400B0. So here it is. Here they are. And it loads. But then it's an address, isn't it? Right, because it doesn't load it by value. It doesn't read it. It loads address. Does that mean that this syscall accepts the size of the buffer by address? Like, why does it store address in there? Can anybody tell me? Because if it doesn't store address, that means what this operation did is read just this thing, first 4 bytes of the message, and it doesn't make any sense. That means it accepts it by an address. What the fuck? So we can try to do the thing that the chat says, just use, you know, move, right? So we can do move directly just to test things. How do you comment out? Okay, so I can probably use the this thing. Okay, so this is move x2. Let's do 16 directly. Can I put 16 directly in here? Right, so I can do something like that. Okay, so obj dump. So, and as you can see in here, so there was 3 words in here before. Since we removed that length, that word does not exist there anymore. And here into x2, we're directly loading 16. Let's see if it's going to work. It still works. So I'm not sure how LDR works, because in first case, it loaded the address where the buffer starts, and in the second case, it read the value from the memory by that address. So it's basically Leo. I suppose it is kind of like Leo, but it's just like I do not fully understand how it works. It's kind of bizarre. It's kind of bizarre. So that also probably means I can try to do move xmcg. All right, so let's give it a try. So it's something like this. So move x1 mcg. Can I do something like that? I can. And it doesn't print anything. So if I do babaji dump, it just puts 0 in there, by the way. It just puts 0. So, but that probably means that what I have to do, I have to prefix it with equals. So let's rebuild. Bad expression at operand. Okay, don't really know what's up with all of that. So I suppose it's better not to question this for now, and just like let it do it like this. Just let it do it like this. Okay, so we'll get this stuff. So this hello from AArch64. So I wonder if I can download this entire thing. How can I SSH into this system? Let me think. So first of all, let's power off it. Let's power off it. Cool. Now, how much time do we have? Well, we'll already spend 2 hours, so everything goes according to the schedule. So what we want to do is sort of like a forward the ports. So this is how I did that in here. So this is how I forwarded the ports. We're going to put this in here. And so here is the netdef user net0, and I also specified this device as a net0. Right, let me put that stuff in here. I wonder if this is going to work. So this is the 2 new lines that I added in here. I'm going to try to run it. Seems to be working. So I'm going to wait until it loads up. And then I'm going to try to maybe SSH into it. So, and I'm supposed to use like user at localhost, blah, blah, blah. Okay, so it's just sort of like tunnels the port. It just tunnels the port. So if I'll be able to SSH into that, that will be actually super cool. That means I can SCP that main out of the virtual machine. So it's loading up. It's loading up. Crony D. So SSH pen probably root at localhost at that specific port, and the port that we specified is this one. Fuck, doesn't work. Can't really do that. Can't really do that. SCP mine streamer at. You think it has to be 10.2.2, not. We can try to do something like that. It doesn't work that easily, fortunately. Can't access it. Can't access it. Even though, like, I set it so it can access these things, maybe I just like run it incorrectly, did I? Is a host IP from ADB. We're not doing ADB, people! Jesus Christ! Okay, bonding. So let's power off. We're not doing ADB yet. For fuck's sake. So run is, so did I specify it? I feel like I might have not, I did specify it, look at that. I did in fact specify it. So, and then I just do that. It's some, is that something with the wrong networking device? Is that not supposed to be E100 or something? Is the OpenSSH installed? Yes, it is, but maybe it's not running. That's the thing. All right, so let's try to do that one more time. That's actually fun. It's really fun. Just explore ARM and stuff. Is the port mapping direction correct? It should be, because I used these scripts before. So, and I just copy pasted from x86-64. I think it's correct. It might be not as like, it might be that SSHD is not running. So that could be the case. Did anybody see here in the logs? Did it start SSHD? Maybe it didn't. Okay, so root bonding. So can I do SSH? It is running, actually. It is running. Maybe it has something to do with IP link. So SSH root at 10.0.0.22. Yeah. Yeah, so it's 2. And then ooh, permission denied though. It might be, yeah, it might be, what is it? The host, right? So 2.2 might be the host. So, and the actual thing in here was IP address, SSH root at 10.0.2.15. Yeah, name, well, I mean space. Yeah, bonding. And I basically connected to itself through SSH. All right, so that's really interesting. That's really interesting. So I connect to itself, but I can't still properly access it. All right, so if I do SSH localhost root at maybe 27.0.0.1, because maybe it just like, you know, resolves into something weird. That could be the case, actually. So localhost might be on my machine resolving to something weird. Still can't access it. Right, so, and the documentation says that I have to do localhost. And none of that stuff, like 10.0.2.15, none of that works. Definitely, none of that works. That doesn't work. And that doesn't work. God damn it. God freaking damn it. So I'm not sure how to, like, what exactly to do. So let me see, run SSH. People are, this is exactly what I'm doing in here, by the way, right? So people saying different things. Right, but that's literally what I'm doing here. So here's the net stuff. Remove nick user. You mean this thing? Okay. So I wanna, that's a good point actually. I didn't think about that. Virch.io, but is it going to break something? Maybe actually, might actually break something. Let's power off it. Why is the device net 0? I have no idea. That's how it's documented. All right. Okay, it's doing things, I suppose. Nick user. All right. Ethoslab. I don't know what you guys are talking about. Okay. So SSH, let's prepare for this one. So we're just waiting until it loads up. I started to use Wirsch. I don't know what is Wirsch. Holy shit, it works. Okay. Bonding. Yo! We SSH'd into that motherfucker. By the way, maybe since we're over SSH, it will be able to properly identify the, what is it called? The terminal and stuff like that. So let's do apk add vim. Right. So I'm over SSH right now. So this is not a direct console, just over SSH. And I have callers finally. So I can now hello vim main.c caller scheme desert. Okay, so I can even have a decent caller scheme on ARM. Finally, freaking finally. So that's pretty cool. If I go hello Azim vim, thank you so much, by the way, for suggesting to remove -nick and stuff like that. Look at that. Finally, what about caller desert? Yeah, boy. Finally. So this is so cool. I now can just run this virtual machine on my other machine, so QEMU doesn't consume all of the resources as I'm streaming. Right, and I can SSH into that machine and have like a proper experience and stuff like that. vimrc, yeah, I need to do vimrc. So it's just like vimrc, and I probably have to like enable some other stuff. So caller scheme desert. Right, and then I can do something like that. And it's automatically like this. See, I know how to use Vim. This is so cool. I really like that. But anyways, so we can now do something like SCP. Right, and might as well move the stuff in here. We going into home, so that means it's a hello Azim main. Bonding. Okay. We got the file. Oh, look how small. It's 1 kilobyte file. It's a 1 kilobyte file. What the fuck? By the way, what kind of ARM is usually used on mobile phones? ARM 32 or ARM 64 on the modern ones? Because I'm not sure like which one do I have. Might not actually work. Both simultaneously. Now ARM 64. I actually have like a cheap ass Xiaomi, how to pronounce it, and I think I want to actually try to do something with it. Depends. I see. So 64 on my favorite laptop. Okay. So if I take a look at this thing, so 64 LSB LDD, not a dynamic executable. Should I try it? Xiaomi 7 is ARM version 7.1. I don't remember which one I have. I think I have a box somewhere. Let me see. Just a second. I don't actually use it, by the way. Yeah, it's a Redmi Note 13. It's this one. So I'm not sure which one is that. Like, I don't actually use it. I just like bought it and put it aside because I wanted to switch to it at some point, but I didn't have time. So it's kind of hard to tell. So we can give it a try. It's a ARM version 8. So it's actually 32 bits, right? So it's not 64, unfortunately. It's actually not 64. Can we build for 32 bits though? I wonder. That's my carbon phone. Yeah. Just a second. Okay. Oh, it is 64. Holy shit. Okay, let's fucking go. Is it alive? All right. So it's loading up. It's doing things. It's a little bit dusty. So it has its own like variation of Android or something like that. Which I don't really remember how it's called. So it's something like Hyper OS or whatever. It's just like, I don't know. What is Redmi? Yeah, so it's a Xiaomi Hyper OS or whatever. So it's probably a modified version of Android. Of some sort. Of some sort. Why you have Wi-Fi modem on the floor? Because why not? It's a Chinese Xiaomi sub-brand. It's even sub-brand. Damn. All right. So let me see. So a lot of things. Okay, do I have... I don't have a spare USB port for this motherfucker. Okay. I'm gonna try to connect through that. So I'm gonna allow debugger working. USB debugging is on. How do I connect to ADB shell? Oh, I did that. All right. that was quick, right? So because I keep forgetting how to do that, and it's just like it's as easy as ADB shell. All right. So and yeah, so I have that, and I have everything. I don't have like CC or anything. So I wonder how to upload a file. So ADB help, ADB push. So can I do help? Because I want to read. So there's a push command. Okay. So push files that are newer on the host than the device. All right. Okay. So ADB push main, and push requires source and destination arguments, but I don't. Do I have to do something like this? Main. Yeah, so the file system is read-only. I feel like I won't be... Oh, so there is a place where I can put things. Data local temp, thank you. So I haven't done any like mobile development for quite some time. I don't remember some of the details. Okay, this is cool. So ADB shell data local I can't tab autocomplete. All right. So holy shit! It works. I don't have compiler on my machine, on my phone. I don't have a compiler on my phone, but I can craft an executable in an ARM virtual machine, push it on my phone, and still run it. This is so fucking cool, because when I bought this phone and was actually playing with it, I was just thinking, okay, I can IDB shell into it, but I can't program in C on that phone. Right, I can't program in C on that phone. Now I can. I can simply craft an executable in a virtual ARM machine, then put it there, and it works. I can do anything in here. I can work directly with syscalls and stuff like that. This is so fucking cool. Holy shit, like I've never been so excited for a long time. Now package this into a PK and install. Yeah. So, but I mean, so I won't be able to do graphical things, I think. I won't be able to do graphical things because what Android has in terms of graphics, it's not X, right? It's not X, it's something else. So I need to be able to kind of connect to that graphical thing. Right, and this is where all of their Android like bullshit layer kind of comes in and does all of that for you. It will be kind of interesting to explore that. Yeah, to mesh Magicon. Yeah. Rayleap supports Android. But if you want to do like a Rayleap Android stuff, you're not doing what we are doing. You're probably doing through NDK and stuff like that. Listen, chat. We created... This is very important. This is very important. We created an executable that just ran natively on my actual hardware phone without Android SDK. Without Android SDK. This is what makes it so fucking cool and so fucking excited. We didn't use any fucking stinky Android SDK. We compiled it with GCC inside of a QEMU virtual machine. This is so freaking cool. Right, so bare metal, yeah, so just like we didn't have to use their bullshit platform SDK or anything like that, and just work. Static linking, and we also statically linked all of that stuff. So yeah, that's so freaking cool. But I mean, it was all created with assembly directly. If I try to do C, I won't be able to use it because it doesn't have the same libc. The same libc is simply not going to work there. Though we can actually test it out. Do we have enough time? I think we have a little bit of time to explore this, because I think we can easily streamline this entire process, right? Can't we? So let me actually put all of that stuff a little bit more convenient for me. Right, so I can SSH into here. All right, so, and for example, here is the hello, right? So here is the main.c. And if I try to compile it with GCC, this is not a static executable, right? So it depends on libc, musl, arch, blah, 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 blah. So maybe it makes sense for me to call it something different, right? So this is hello c musl, like this. So this is what it is. So the reason why I do it like that, because now I'm trying to get it out of here. So this is just hello c musl, right? So bonding, and now so here is an executable. It's a little bit bigger, but it also depends on musl. Not a dynamic executable, but this is because it just literally didn't recognize it. Yeah, so it's dynamically linked. So then I can do adb push, and we're going to be pushing this thing into here, right? So adb shell. I'm inside of my phone, right? So I go into data local tmp, like so. And here it is. This is on my phone. This file is on my phone. I can try to run it, and I can't do that, right? So because it doesn't have that musl, right? So I can do this kind of trick with static, but with C, I'll probably have to link it with static. Let's give it a try. Right, so let's actually give it a try. I wonder if I can... Okay, so I have a little bit of a weird splitting in here. So here's the virtual machine running. Let me create another window. I'm going to do SSH. Right, so this is bonding. And so where is this thing? So GCCO, let's do static. All right, so if I take a look at the main cmusl, it is static executable, not a valid thing. It works. So now in here, I can do scp. I can just load it in here. Then I can do push. That should replace it. Shell. Can I? Oh, that's very... Okay, that's... I don't know how to do that. Local tmp. Absolute trading. Absolute trading. You know what that means, chat? You know what that means? I can now write more complex applications in C. What if I write something more complex? What if I write Fibonacci number generator? So something like this. So while A is less than, I don't know, 1 million, right? So in here, what we're going to be doing, we're going to be printing the number like so. Then we're going to create C, which is A plus B. B is going to become C, and A is going to become B. All right, so then I'm going to do GCC. So we didn't, yeah, so we need to fix that super quick. It's going to be A. So GCC. So just a second. Here it is. Main cmusl. Here's the Fibonacci number generator. Cool. Now in here, I'm gonna basically scp the whole thing. Then push adb shell data local tmp. Can I do something like that? Yeah, I generated Fibonacci numbers on my phone. So that's pretty cool. I can now load my phone with something, like I can crunch some numbers on this thing, right? So here's the thing, I can use it for crunching numbers. So that's pretty cool. That's actually super cool that I can just like use it for crunching numbers and stuff like that. So this ain't Fibonacci though. Yeah, that's weird. That looked kind of weird. What is it? Wait a freaking second. So did I do a fucky wacky? Ooh, that could be the... Actually, I did fucky wacky. So A plus B. Yeah. So did the fucky wacky? Right, so this becomes that. GCC. Where's the static? Now that looks like yeah. Wait. Yeah, this is Fibonacci. Yeah, 1, 2. There we go. So now, can I maybe do something like this? Can I, what is it, SCP, boom, bonding, then push, boom, then I can close it, and in here, now that's Fibonacci, right? So now I can officially say that I computed a Fibonacci sequence on my phone. So I officially freaking did that. Absolute shredding, absolute shredding. Okay, I've got some notification. Oh, it's Xi Jinping saying that I should not hack his phone. Oh, okay. I'm sorry, Mr. Xi. I'm not going to do that anymore. All right. So, and we're already finishing this stream anyway, so that's pretty cool. That's pretty cool. So thank you everyone who subscribed. We have a lot of new subscribers. Mr. Foss, thank you so much with the message Sodium Poking. Prada Veal, thank you so much with the prime. Pre-recorded thoughts, thank you so much. Ali Mark 71 with a message. It would be interesting to imagine you on a Swift Docs workshop. I don't know what it is, but I mean, I don't usually go on any conventions or event or anything like that. I'm pretty asocial person. Thanks Zero, thank you so much for tier 1, and AA709, thank you so much with Twitch Prime. This was actually super cool. I didn't really expect to have so much fun, like tinkering with this entire stuff. We had a lot of troubles, but we together, as a community, managed to overcome all of this trouble. So it was a sort of like a collaborative effort. Sometimes chat is very noisy and very useful, but sometimes someone just says something useful, and that's why occasionally I look into the chat, and I really appreciate you occasional people who help me with random bits and stuff like that. So yeah, that was cool. That's it for today. So we're gonna explore this kind of stuff even further. The whole point was to have some sort of ARM setup. Right, so now we have an ARM setup. Now we can do a lot of cool things with ARM. And on top of like having a virtual machine, we have an actual ARM64 hardware that we can test all of that stuff on without any emulations or anything like that. Actual cool shit. Okay, that's it for today. Thanks everyone who's watching right now. Really appreciate that. Have a good one, and I see you all on the next recreation programming session with Mr. Azozin. I love you. Mwah.